11.3 Magnitude and Direction. Before we delve too far into magnitude and direction, let's just consider a boat that's travelling with the vector a, which is 3i plus 4j meters per second. What does this actually mean? Can we work out the magnitude, or the speed, and the direction of travel of the boat using more conventional units? Let's start by drawing the vector. Here, vector A is the red line, and we can see that it has 4i plus 3j as its two component parts. If the boat is travelling in this direction, how fast will it actually be travelling? It isn't travelling 4 units east and then 3 units north. It's just going direct from this point to this point in the direction of A. We're just describing it using 4i plus 3j. How could we work out how fast it's travelling? We can use Pythagoras' theorem. To work out the magnitude, we would do 4 squared plus 3 squared, which is 16 plus 9, which is 25. So the magnitude of A would be the square root of 25, which would be 5 meters per second. We indicate that we are finding the magnitude with straight lines on either side of the vector, as shown here. Unit vectors are vectors that have magnitude 1. A unit vector in the direction of A is A over the magnitude of A. If the magnitude of A is 5, then a unit vector in the direction of A is A over 5. Example 11. We're given two vectors, A and B. We're asked to find the magnitude of A unit vector in the direction of A, and the exact value of 2A plus B, the magnitude of. So, for part A, the magnitude of A, well, 3i plus 4j is going 3 in the x direction and 4 up, so we can find it by doing the square root of 3 squared plus 4 squared, which would be the square root of 25, so it would have magnitude of 5. For part B, a unit vector in the direction of A, we would need to take vector A, which is 3i plus 4j, and divide both components by 5, as that's what we found our magnitude to be. We'd be left with 3/5 I plus 4/5 j. This could be written like this. We could take a factor of a fifth out, or we could even write it as a column vector in decimals. In part C, we're asked to work out the magnitude of 2A plus B. In order to do this, we need to start by working out what 2A plus B is. Well, 2A plus B would be 6i plus 8j, that's 2A, minus 2i minus 4j, there's B, which will leave me with 4i plus 4j. The magnitude of 4i plus 4j could be given by doing the square root of 4 squared plus 4 squared, which is the square root of 32, which would be 4 root 2. We can also define a vector by giving its magnitude and the angle between the vector and one of the coordinate axes. This is magnitude direction form. In example 12, we need to find the angle between the vector 4i plus 5j and the positive x-axis. Well, 4i plus 5j would be 4 along and 5 up. So the angle that we're looking for is shown as theta here. In order to find this, I'd use some basic trigonometry. tan theta equals 5/4. So theta would equal 51.3 degrees to 3 significant figures. Before we look at example 13, we're just going to start a small bit of mechanics. If you're doing A-level physics, this will hopefully be very straightforward. If you're not, pay attention. Imagine you've got a force of 20 newtons that's pulling at an angle of 30 degrees from the horizontal. When you pull in that direction, some part of the force is pulling horizontally and some part will be pulling vertically. So my 20 newtons in this direction will pull some object in this direction, but also upwards. If this was a steeper angle, then that would increase the amount of pressure that we're applying, pulling upwards, not the right word, and would decrease the amount of force we're pulling with in the horizontal. So how can we work out exactly how much of this 20 newtons is working horizontally and how much is working vertically? What we can do is we can split it into its ij components. What that means is we're going to look and see how much of the 20 newtons is pulling in the I direction and how much is pulling in the j direction. All you need to remember is that if you turn through the angle, it's cos. That is the key phrase. Here, we've got 20 newtons of force, and if we were to pull that force down through the 30-degree angle, we'd be turning through 30 degrees. So it would be, in this direction, 20 cos 30. In the other direction, we wouldn't be turning through the 30-degree angle, we'd be going the other way. So that would be 20 sine 30. We could work those out. 20 cos 30 would be 10 root 3, which would be 17.32 newtons. And 20 sine 30 would be 20 times a half, which would be 10 newtons. So the 20 newton force at an angle of 30 degrees could be considered to be a 17 and a bit newton force in the horizontal and a 10 newton force upwards. Now let's look at example 13. Example 13. We're given vector A and we're told it has a magnitude of 10 and makes an angle of 30 degrees with J. Find A in I, J and column vector format. We have 10 newtons being pulled at the angle 30 degrees from the vertical. I would look at this and say this is turning through 30 degrees, so the J component will be 10 cos 30. The 10 newton force, and we've turned through 30 degrees. In the I direction, we would have 10 sine 30 because we'd be going the other way. Now, what they've done in the example is a bit trickier in my mind. They've started by drawing in the horizontal and then they've used some trigonometry to work out the y component and the x component using the 60-degree angle. Why they didn't draw a line in here and use the 30 degree that was given, I don't know. Regardless, I think this overcomplicates things. We still end up with the same answers. 10 sine 30 is 5 and 10 cos 30 is 5 root 3. So, long story short, if you turn through the angle, it's cos. If you turn the other way to find the other component, it's sine. Use that and you won't go far wrong. Now I'd like you to work through exercise 11C and of course ask me if you've got any questions or queries. Many thanks.